All right. So yeah, thanks everyone for joining. And today we are going to have a small discussion on VXLAN routing. Um, Most of you have, undergone through that training, and whatever I'm going to do, you can recollect that. So, but mostly it will be targeted for, Navneet and Sandeep. Okay, I think Sandeep Mogal hasn't joined. Just
No, I'm here. I'm here.
oh, sorry, I think I missed that. Okay, yeah, cool. So yeah, it will be target for you too because I think you haven't went through that training that others have. So if any point anyone has any question, feel free to ask. And this is going to be an important topic. Essentially, what I'm expecting after this challenge is everyone to be thorough with these concepts. And let's say if you get any case, you are not confused how the packet would encapsulate and everything. So that's the expectation. And once you are done with this, you can also you can also try exploring the advanced topics like EVPN. Okay. So with that said, let me share my screen. Just give me a second. Okay, so we'll discuss about this. We'll discuss about the concept of Anycast VXLAN routing, which is the most important topic. I hope everyone is familiar with VXLAN bridging. And before I start with that, does anyone wants to ask something on bridging and VXLAN routing in general, not Anycast, but just normal VXLAN routing, inter-VLAN. If anyone has any question, we can do that before I move here. Navneet, Sandeep, feel free to ask if you have anything you want to.
No, I'm good.
Okay. Navneet, are you good?
Yeah, Aniket.
Okay.
Thanks.
All right. So let's start then. So you see this topology, right? So let's try to build this where Anycast is needed or how is Anycast needed, right? What is the meaning of Anycast? So in general, if you see here, we have two routing VTEPs, VTEP 1 and VTEP 3. Okay, and we have this H1, which is a VM hosted on ESXi. And this is a spine device that is connecting all the VMs, right? And this part is known as a underlay, right? Which is providing the reachability between all the VTEPs. Now, a very common practice that customers do is called vMotion, right? Where let's say this host's IP is 100.1.1.10, the gateway is 100.1.1.3, right? And it has already learned the R, which is pointing to the MAC address of VTEP1. Okay, so VTEP1 MAC. Now, in this case, if we move this host from VTEP1 to VTEP3, which is what vMotion is, in that case, it will contain the same information, right? It will still have this same gateway IP and same gateway MAC address. In this case, if H1 has to reach its gateway, what will happen then? It will send a packet here, then it will go here, and then essentially it has to come here. So is this a good solution? No, right? So yeah, so this is something that customers don't want, right? Because it's inefficient to just to send traffic to your gateway. You are crossing other data center. So how do we handle this? So what do you think that we need to do here, or what do you think you need to bring here to address this issue? Where every VTEP has its own VTEP gateway IP. So if you see on VTEP 1, the SVI 100 is 100.1.1.1, and on VTEP 3, the SVI IP is 100.1.1.3. So what do we need to address this issue? Can anyone guess? Let's keep it interactive, okay? It'll be more fun if everyone participates.
Can you reiterate the question?
Yeah. So my question is, how do we address this issue where initially when we were moving H1, it the gateway IP was still pointing to VTEP1, right, which is across a different data center. So how do we address this issue? Right now, every VTEP, every routing VTEP has a unique SVI IP.
we can create the same virtual IP on all the VTEPs, routing VTEPs.
Right. Okay. So we went to the next step, and let's say now we created a virtual IP. Okay. Actually, before that, let me show you one more problem. This is still not virtual IP. So we have a host here, right? H2, and for H2 is connected to VTEP2, which is a bridging VTEP. Okay, and for H2, the gateway IP is, it can either be VTEP1 or it can be VTEP3. Okay, so let's say in this case the gateway is 100.1.1.3. So again the same issue, right? If H2 has to send any traffic, it will always go to VTEP3. And if in case this VTEP3 reloads or fails or something, then there can be a traffic loss. Right? So we need to introduce virtual IP, which we introduce here. Okay, so now we have a virtual IP. Does this solve the issue? So now you see on H1, the gateway is 100.1.1.1, which is a virtual IP. It is configured same on both routing VTEPs. And the gateway is VTEP1's MAC, the MAC address. So does it seem like a good solution if we move this host here?
We need virtual MAC also.
Yeah. Right. And similarly for this host also, if you see, it can only map this 100.1.1.1 to one of the VTEP's MAC, either VTEP1 or VTEP3, whichever ARP reply is received at the last. So in this case, it has learned the MAC address of VTEP3. So again, if H2 has to send any traffic to its gateway, it will always go to VTEP3, which is also we don't want. Because let's say if this VTEP3 goes down, then again H2 will keep sending traffic to VTEP3. Right? So we need virtual MAC, as you told, right? Okay, so now the next scenario, we introduce virtual IP plus virtual MAC. So now if you see, we have this virtual MAC, right? 00A, 00B, 00C, and it is configured on both the routing VTEPs. Okay. Now, does it solve host one's issue? If I move host one to here, is this issue resolved? Yes, no?
Yeah.
It resolves, right?
Yeah, response.
Yeah. Because now when H1 has to send any traffic, it will send to the DMAC of virtual MAC, which is configured on VTEP3. So VTEP3 can route and send. It doesn't have to send the traffic to VTEP1. So this is all good. But what about H2? So remember, H2 is connected behind a bridging VTEP, which doesn't have SVI, right? So if H2 sends traffic to its gateway, 00A, B, and C, so the traffic will come to VTEP2. And where will VTEP2 send it to?
First, it will send a broadcast.
Broad.
I mean, let's say if it's an ARP request.
Okay, so let's say you mean the ARP is not resolved. Okay, cool.
Yeah.
So H2 sends an ARP request for its gateway, right?
Yeah.
And this VTEP2, it'll flood that ARP request to both VTEP1 and VTEP3.
Yeah.
Correct?
Yes.
What will happen is both VTEP1 and VTEP3 will send an ARP reply. Okay. But there is a problem. Okay. When they will send this ARP reply, the inner source MAC will be the virtual MAC, but the outer source IP will be the primary VTEP 1111. So what you will see here is when it will receive that VXLAN ARP reply, the two VXLAN ARP reply, it will flap. Okay, so first the VMAC will be point to VMAC 11111, and then it will map to 33333. Okay, this will flap. So, and also this host will unnecessarily get two ARP replies. Okay, so now this is not that big of a problem. The problem comes if this, again, the mapping is constant. So let's say this on VTEP2, the VMAC is constantly mapped to 3333. That's the problem. Why? Because anytime H2 will send the traffic to its gateway VMAC, it will always go to VTEP3, right? And if there are multiple hosts behind this VTEP2, it will always go to VTEP3. And in case VTEP3 reloads or something, it can again black hole, because this MAC learning will still be present. So that's the problem. So what do we need here?
So we need a additional VTEP IP which can be used if there is same SVI.
Virtual VTAP.
VTEP.
This is where your VVTEP comes. Okay. So VVTEP is nothing but a secondary IP on the loopback interface, which is part of VXLAN. Okay. So you see this. Now let's see how this solves the issue, right? I mean, H1 issue was already solved. For H2, this VMAC will be pointing to VVTEP IP, right? Now, any traffic that H2 will send destined to its gateway VMAC, it will come to VTEP2 and it will encapsulate with the outer destination IP of 5555. That will go to spine, and on spine you will have a ECMP route. Okay, so 555 will pointing to both VTEP1 and VTEP3. So it can hash the traffic to either VTEP1 or VTEP3. And in case any of the VTEP reloads, that route will be removed. Okay.
Yeah, okay. This is a loop for loopback, which is mapped to the VX1, right? So
yes,
it will take secondary IP for, or I mean, like.
I'll get to that. I'll get to that. What you're asking, we'll get to that. But when this, let's say this H2 is sending an ARP request, okay? When it is sending an ARP request for the virtual IP 100.111, when it will be reaching VTEP1 and VTEP3, right? So in this case, what happens is only the VTEP who receives the ARP request destined to the outer destination IP of VTEP will reply. Okay, so let's basically when VTEP2 is flooding that ARP request, right? So it'll check its flood list, right? And in its flood list, what are the IPs it has? 1111, 3333, and 5555. Okay, so one ARP request will go to 1111, which is VTEP1. One will go to VTEP3, which is 3333. And this 5555, whoever receives that 5555, right, with outer DIP as 5555, only that VTEP will respond to that ARP request. So when they are getting the ARP request destined to this VTEP IP 1111, they will not respond when VTEP is configured. If VTEP is not configured, then they will have to respond. I hope this difference is clear. So if VTEP is configured, VXLAN, so routing VTEPs reply to VXLAN ARP request only if outer DIP is VTEP. Okay. But if VTEP is not configured, then obviously it has to respond. If no VTEP, it will always respond. So in this case, only the routing VTEP who gets the ARP request with a destination IP of 5555 will respond. And H2 will get only one ARP reply. Whereas earlier, H2 was getting two ARP replies from both the routing VTEPs. Is it clear, Sandeep, Navneet, this difference?
Yes,
or we
it
can.
is.
Okay.
Aniket,
Yes.
now spine will hash either to VTEP1 or VTEP3 in this case. So VTEP, the 555 IP should be mapped to one MAC address, right? So is that MAC address the VMAC, or we have a different MAC configured?
That is a VMAC, right? So
Okay.
once host 2 learns ARP for the virtual IP, which is, you can see here, the VMAC, right? So any traffic it has to send to its gateway, what will be the DMAC? It will be the virtual MAC, right?
Yeah.
And
Got
when
it.
VTEP2 will get that packet, it will see where is the VMAC learned, right?
Yep.
So it will see that the VMAC is, it will be always be learned to be VTEP. If VTEP is configured, okay, you will never see that VMAC is pointing to a normal VTEP IP. It will be always be pointing to VTEP.
Yep.
Okay, so then traffic can go to any of the routing VTEP, and then there can be many other routing VTEPs. Traffic can go any one of them.
Yeah.
Aniket, Navneet this side.
Yeah.
This one, you told that it is going to be, let's say we have multiple VTEP configured. Then any criteria or decision making on which is going to be take the traffic?
No, I didn't say multiple VTEP. What I meant is there can be many other routing VTEPs. Okay, just like VTEP 1 and VTEP 3, there can be a VTEP 4, okay, which is a routing VTEP. And what I'm saying is, when H2 is sending packet to its gateway, which is a virtual MAC, right? That traffic can go to any of this gateway. It can go to VTEP 1, it can go to VTEP 3, or it can go to VTEP 4. Because that 5555 is configured on all these routing VTEP, which is a VTEP.
Okay, it can go. I mean, can we forcefully configure that it should consider like one particular VTEP need to be take the traffic only, and other can work as a standby?
If we have VTEP, I don't think we can do that. I mean, there can be some scenarios where you can configure different VTEP, but that is a very different scenario. Usually, a virtual MAC is always mapped to a one VTEP. I mean, you can make some scenarios where you have a virtual MAC pointing to different VTEP. But what we are trying to achieve here is the traffic should not always land to a one VTEP. It should be hashed to different VTEPs. So we want to load share that. If you always keep on sharing to one particular VTEP, if that's something not desirable. Okay. So we want to load share that traffic.
Fine.
Aniket, I have a question.
Yeah.
So H2 is sending ARP request to 1.1.1.1, 3.3.3.3, and 5.5.5.5, right?
Yeah.
So let's consider the first packet 1.1.1.1. So VTEP 1 receives that packet, and VTEP 1 looks through it and it decapsulates the packet and it reaches the ARP request. So will it populate its MAC address table or will it just discard the ARP packet?
It will. Good question. It will learn the MAC, but it will not flood it. So what happens is any VXLAN ARP that we receive here, right? It will be, and this is applicable for hardware also. Any VXLAN ARP packet that you would receive, okay, it will always go to the CPU, and it is managed. It is handled by the VXLAN software forwarding agent, and in that agent, it has a rule. It checks certain criteria that what is the inner DMAC, what is the outer DIP. It will check all those things. So if it sees that the outer DIP is not a VTEP IP, while the inner DMAC is a VMAC, then it will discard that packet. But I think it should learn the MAC address because essentially it should know who sent the packet. So, but we can check that in lab. I don't remember at this point, but mostly it should learn the MAC.
I think it learns, Aniket. So when we see the show ARP, right, the interface would be VX1, I guess.
Yes, yeah. It doesn't learn the ARP. Okay, it won't learn the ARP, I believe.
Yes.
So but good question, and we'll definitely check that in lab. Okay, how that works out. Okay, but this part is, the core concept, and I just want to take some moment here. If there's anything else, there is many way you can break here, right? Like you can configure different VMAC and same VTEP IP. You can configure same VMAC, different VTEP IP, or you can have two data centers where in one data center you have one VMAC, another data center has also has the same VMAC but different VTEP. So there is many way you can be creative, and you can, but whatever you are learning here is applicable everywhere. It's just that maybe you're changing the scenario, but the basics doesn't change. Okay, so you have to think of the same rules and apply there. What will happen there? Okay, any other questions? Sorry, I think Shweta, can you mute yourself? There's some.
Sorry.
Yeah, no worries.
Yeah, Aniket, I mean, it's not related particular to the this one VXLAN, but the requirement was that let's say the H1 or H2 is moving and in different data center, then the gateway is required to be pointed, and it's not need to be changed. So is it not possible that this can be assigned dynamically data center wise? I mean, if it is connected to the VTEP 3, then in that case, it should change the gateway itself, I mean, dynamically or DHCP.
So are you talking about the host or?
Yeah, host. I'm talking about the host.
That I mean that depends on many other hosts. Like I'm not sure, but let's say if that is possible, if you know if it changes the gateway, then that depends, right, on the other data center what is configured, whether it has a same virtual IP or same virtual MAC, all those things. But anything from the VTEP perspective that you want to ask, because from the host perspective, that can depend from OS to OS. Some may support it, some may not. I'm not sure.
Okay, fine.
Yeah.
Aniket,
but that said, sorry, go ahead.
Sorry. Yeah, Aniket, this outer, I mean, like whenever a request is coming with the outer, ARP request is coming with VVTAP IP, you're saying that the ARP reply would be processed, else it will be dropped, is it?
If VVTIP is configured and if it receives a VXLAN ARP request with the outer DIP as not VVTIP IP, then it will drop.
Okay, so when VVTAP is configured, the request should also come with the VVTAP.
Yes, yes.
Okay.
Okay. So any other questions? Then we'll move to the different types of virtual IPs and we'll see what are the differences.
But even if the destination IP is VTAP instead of VVTAP, if you receive an ARP request for the physical IP, it will respond.
If VVTAP is not configured, then if it receives the ARP,
VVTAP is configured. VVTAP is configured. And if it receives an ARP request for physical IP with destination IP as VTAP.
Physical IP. Yeah. It will respond.
Correct. Only if it's virtual and it receives, if it's
correct.
ARP request is for virtual IP and the destination IP is VTAP, it won't respond.
Correct. That's correct.
Okay.
Yeah. So even if you have, like, let's say you have configured the virtual MAC and you have configured the virtual VTAP, but your SVI that you have is not a virtual IP, like 100.1.1.10/24. In that case, it is, it has nothing to do with virtual MAC. So if it receives the ARP request destined to 1111, which is primary VTAP, then it will respond. And when it will respond, it will send its physical MAC address. Like the sender MAC will be the physical MAC. Whereas if the ARP request is coming for the virtual IP, then the sender MAC in the ARP reply, the sender MAC will be the virtual MAC.
What about the other case where it receives a request for the physical ARP request for the physical IP, but the destination IP is VTAP IP? Then also it will respond. Right?
It will respond.
Yes.
Because this has that virtual VTAP is only associated with your virtual IP. Okay. So, but if it is just a physical IP, right? SVI physical IP, then it doesn't matter, right? Then it is just like normal routing. If it gets a ARP request for this physical IP, it has to respond. And when it will respond, it will never send a virtual MAC, right? Because it's its own IP, not a virtual IP. So it has to send the physical MAC information.
Thank you.
Okay. Any other questions, guys? Anyone? Feel free to ask. All right. So we'll talk about so basically when I'm talking about virtual IPs, right, here. So there are two types of virtual IP that we generally use. So you must have heard of, first thing is you must have heard of VARP, right? IP virtual router address. So this is something that we configured with MLAG, but it can be used without MLAG also. So this is one type of virtual IP, and another is IP address virtual. Okay. So in VARP, right, whenever you are configuring VARP, you would need to configure, like, let's say you have SVI 100, right? So you have to configure physical IP first. Okay, so 100 IP address 100 1.1.10/24, and then you have to configure the virtual IP virtual router, IP virtual router address, whatever, right? So what we are doing is, if you want to configure the virtual IP, you have to always configure the physical IP. Okay, and on all VTEPs, right? On all routing VTEPs, there will be unique physical IP. Okay, so like in this case, if you see, the physical IP is 100.1.1.100, and here it is 100.1.1.200. But the virtual IP is same, 100.1.1.1, 100.1.1.1, and obviously the VMAC is also same. Okay, so what are some of the rules that you need to remember in VARP? Okay, first of all, in VARP, any ARP request that this VTEP will generate, it will always have the source MAC as a physical MAC. Okay, Ethernet source MAC will always be physical. The ARP sender MAC will be physical, and the ARP sender IP will be the physical IP. Okay, so let's say if this VTEP1 wants to send an ARP request for H2 or H1, it will always, everything it will be sourcing with is physical MAC, physical IP. Now, why this is important is, whenever your inner source MAC is physical, okay, whenever your inner source MAC is physical, your outer source MAC is, your outer VTEP IP is also the physical VTEP IP. And that is kind of the logic, okay, because you want to map the physical MAC to a physical VTEP, not to a VVTEP, right? Because you know this physical MAC exists only on VTEP1. It doesn't exist on VVTEP. If it exists on VVTEP, then the packet destined to VTEP1 can go anywhere else, right? So whenever the inner source MAC is physical MAC, the outer source IP will always be the primary VTEP IP. And if the inner source MAC is a virtual MAC, then what will be the outer source IP? It will be
VVTEP IP.
It will be VVTEP IP. Okay, because you want to map the VMAC to a virtual VTEP IP. Okay, so that is the first rule, that all ARP requests is generated with the physical MAC. Second is, whenever anyone, right, if whether it is H1 or H2, H1 is a local host, H2 is a remote host, from the point of view of VTEP1, whether H1 or H2 sends an ARP request for the gateway IP, which is 100.1.1.1, VTEP1 will always send the ARP reply with its virtual information. So the Ethernet source MAC will be virtual MAC. Inside the ARP sender MAC will be virtual MAC. The ARP sender IP will be virtual IP. Everything will be virtual. Okay, so any host sends an ARP request for its virtual IP, for its gateway, then the ARP reply will always be virtual, and it has to be, because if VTEP1 sends a ARP reply with its physical information, then H1 will not learn this VMAC, right? It will learn the physical MAC, which we don't want, right? So this is the second thing that you need to remember. All ARP reply is sent with virtual information. Okay, and in VARP, we also send a GARP reply, okay, to inform where the to update the ARP on the host side. So it always sends a GARP. And in the GARP also, the source MAC is virtual MAC, and the ARP sender IP, sender MAC, everything is virtual. Okay. And as I told this, that whenever the inner source MAC is physical MAC, the outer source IP is always a primary VTEP. If the inner source MAC is VMAC, the outer source IP is VVTEP. So these are very simple rules. Like just, you know, you don't have to remember also, you just need to understand why it is like this. Then, you know, you'll never forget. But yeah. So yeah, this is, you know, this is one ARP request that is generated by SVI 100. And this you can see here, when it is, all the information is physical MAC. Sender MAC is physical, sender IP is physical. And because the Ethernet source MAC is physical MAC, the outer source IP will be the physical IP 1111. Okay, and if the ARP reply is always virtual. And after encapsulation, the outer source IP will be the VVTEP IP. These are the fundamentals that you need to remember about VARP. Any questions?
Yeah, Aniket, the rules, can you just scroll down?
Yeah.
Yeah, this an example of this fifth and sixth. Is it like, say for example, is it initiated from the device itself, or you're mentioning about the end host for 5 and 6? It's from the leaf device VTAP.
It is from the
Is
perspective of encapsulation,
okay.
from encapsulation point of view. Okay, so
Okay.
whenever VTAP 1, okay, whenever VTAP 1 is sending an ARP packet, uh, whether it is an ARP request or reply. So whatever these rules I'm saying is from the point of view of encapsulation.
Okay.
Okay. Yeah, this is about ARP, okay, and there are a couple of other things there are also you can also ask about ICMP. Okay, whatever we are discussing is ARP because that is more important. But we'll discuss about ICMP also, how ICMP the behavior changes. But generally, you need to know what ARP, how the behavior works for ARP, because we don't ping from VTEP that much. Okay. Any other questions? And then we'll move to the IP address virtual part. Okay. So IP address virtual is also not very different, I would say, but obviously there are certain things that are changing, and we'll discuss that. Let me just copy this diagram. Okay, so let's first of all, in IP address virtual, you don't have to configure a physical IP. Okay, so in VARP, if you, as I told you, you need a physical IP, but in IP address virtual, you just need the virtual IP. So it will be like 100.1.1.1. So IP address virtual. This will be the VIP. So the command would be IP address virtual 100.1.1.1/24. Okay. So that's all. And you still have the VMAC. You still have the VVTAP IP. And this will also be same thing. IP address virtual 200.1.1./24. Okay. And similarly, same thing you have here. Okay, is exact virtual IP. You have it here also. And you have the same virtual MAC on both sides. So in IP address virtual, whenever these are the rules, okay, whenever it sends an ARP request, the source MAC will always be the VMAC, and the sender MAC will be the virtual MAC. Sender IP will be the virtual IP. It's basically the opposite of VARP. In VARP, everything was in the ARP request, everything was physical, whereas in IP address virtual, all ARP request is virtual. Okay. This is same as VARP. The ARP reply is sent with virtual MAC and sender IP. Everything is virtual for ARP reply. It has to be, because whenever you're responding to your host with your ARP information, you have to send your virtual information, not your physical. Okay, and there is no GARP here in IP address virtual. Okay, so if any host has to refresh its ARP, then it has to send an ARP request. This can be a separate topic why there is no GARP, but this is what it is. IP address virtual, it can be considered to replace VARP, because if you want to save IP address in your subnet, okay, so let's say if there are 50 VTEPs, you would have to configure 50 physical IPs if you use VARP. But in IP address virtual, it's just one IP. So that is one beneficial. And again, the same rule is applicable here. If the inner source MAC is physical MAC, the outer source IP is physical VTEP IP. If the inner source MAC is VMAC, outer source IP is VVTEP. Same thing. Okay. These are the basic things. Now there are a few things that we'll discuss here with IP address virtual. First of all, any question so far? Or am I going too speed or like going too fast, or do I need to slow down? Let me know. Okay, I hope, feel free to ask. Okay, I hope it is fine. Okay, so let's compare one thing. Okay, in VARP, if you, as I told you, all ARP request is whenever it sends an ARP request, everything is physical, as I told you, right? Now, what does that mean? If this VTEP1 sends an ARP request for H2, okay, if this VTEP1 sends an ARP request for H2, the inner source MAC will be the physical MAC, and the the ARP sender IP will be the physical IP. Okay, so everything is physical in ARP request. So when this H2 will send the ARP reply, when it will send the ARP reply, what will be the DMAC of the ARP reply?
So VTEP1's physical MAC.
VTEP1 physical MAC, correct. Okay, I'm just writing VTEP1 MAC. Okay, that means VTEP1's physical MAC. Now, when VTEP2 will get that ARP reply, it will see that VTEP1 MAC is pointing to which VTEP IP?
1.1.1.
1.1.1, right? So this ARP reply will always reach VTEP1. There is no doubt about that, right?
Correct.
Let's say, you know, if I introduce MLAG, okay, just one thing I want to clarify. Let's say this is VTEP4, okay, and this is also routing VTEP. And in MLAG, all configurations are same with respect to VXLAN, okay? Like VTEP1 and VTEP4 will have exact configurations. Now in this case, when VTEP1 is sending an ARP request, when VTEP1 is sending an ARP request for H1, okay, and when H1 is sending and this is a port channel, okay, this is a MLAG port channel. When H1 is sending the ARP reply destined to the VMAC, destined to the physical MAC of VTEP1, if it goes here, then also what will happen? ARP reply will reach here, right? Because the DMAC is VTEP1, right? So with VARP, we are always ensuring that the ARP reply is always received where whoever is requested. Is it clear for everyone?
Yes.
Okay. All right. Now let's see in IP address virtual how that changes. Okay. In IP address virtual, I told you all the ARP request is initiated by the virtual MAC. What does that mean? When VTEP1 will send an ARP request for H2, the inner source MAC is going to be virtual MAC, which means if this host sends an ARP reply, what will be the DMAC?
Virtual MAC.
It will be virtual MAC, correct? Now, this VMAC is pointing to where?
5.5.5.
5.5.5, which is a VTEP. What does that mean is this ARP reply after encapsulation with outer DIP as 5555, it can go here, VTEP3, right? Because VTEP3 also has the same 5555. Are you following, Navneet, Sandeep?
Yeah, Aniket.
Okay. So if it receives on VTEP3, then what will happen? The ARP request is generated by VTEP1, right? So in this case, we do a ARP sync. Okay. So whenever, this is the rule for ARP sync, that whenever routing VTEP, when a routing VTEP receives a VXLAN ARP reply, okay, focus on this, reply, okay, not for request, with a outer DIP as VVTEP, it will perform ARP sync. Okay, and what is ARP sync? It will flood that ARP request it'll flood that ARP reply, okay, to all the VTEPs. It will flood the VXLAN ARP reply to all VTEPs, except from where it came from, which is 2222, who is the, like, this ARP reply came from here, right? So it won't flood it to 2222 and 5555, because 5555 is its own IP. Okay. Yeah, so it will flood it to 1111. Now, when it will flood that ARP reply, it will do one thing, okay? It will do something. It will change the inner source MAC, okay? So if you see here, when it gets that VXLAN ARP reply, initially the inner source MAC is going to be H2, who is sending the ARP reply. But when VTEP3 will sync that ARP information, when it will flood that ARP reply, it will change that source MAC from H2 to its own MAC in the process of ARP reply, okay? In the process of ARP sync, VTEP3 will change the inner source MAC from H2's MAC to its own physical MAC. Now, can anyone tell why is that needed? Why are you doing that? Can anyone try to take a guess? Just think of it, right? If what will happen if the inner source MAC doesn't change? What will VTEP1 think?
Forward to the H3 VTEP directly. So
yeah, right. So if VTEP1, if VTEP3 doesn't change the inner source MAC from H2's MAC, now that VTEP3 will flood that ARP reply, it will encapsulate and it will give the outer source IP as 3333. What does that mean is, on VTEP1, the MAC address of H2 will be pointing to where? VTEP3, which is wrong, right? So basically it will completely change that source MAC. Now what will happen is, on VTEP1, you will see that the ARP is learned, the ARP of H2 is learned, okay? Like you'll see something like this, 100.1.1.20 with a MAC address of H2, but you will also see not learned. What this not learned mean is, this MAC address, H2 MAC address, is not learned on VXLAN address. It's not, this MAC address is not learned in the MAC address table, but the ARP is learned. So if VTEP1 has to send any packet to 100.1.1.20, it knows what will be the DMAC, but it doesn't know where this DMAC is learned. So what will it do?
It will flood to all the VTEPs.
It will flood to all the VTEPs, correct? And that is better than black holing. That is better than sending that packet to VTEP3 and getting black holed. So we would rather want to flood it rather than black holing, okay? So that's the reason. And this is kind of a limitation with this kind of design, okay? Any questions so far about this concept? Why are you doing the ARP sync? Why are you changing the inner source MAC in the ARP sync? Navneet, Sandeep?
No, Aniket, I didn't get that ARP sync part really.
Okay, so from where? Okay, let's start again. So we are discussing about, we are talking about VTEP1 resolving ARP for H2. Okay, so let's go step by step. So VTEP1 will send an ARP request for H2. Okay, so as I told, right?
That's fine. I mean, the step, the second step you written, when the H2 will reply with its, I mean, MAC and the DMAC and this one, the virtual MAC, and it will receive by the VTEP3 also. Then VTEP3 is going to do the ARP sync, correct?
Yes. By ARP sync, it just means that it is flooding that ARP reply. It is sending it back into VXLAN. So it received that VXLAN ARP reply on VXLAN tunnel. Okay, and when this rule is hit, when this rule is hit, then it will do the ARP sync.
Okay, and that when it's reflooding, then it's changing the source MAC, correct?
Yes, it is changing the inner source MAC, which is H2.
Okay.
Because if it If it doesn't change, then on
Mhm.
VTEP 1, the MAC address of H2 will be pointing to VTEP 3.
Okay, fine.
Yeah. So Sandeep, is it clear?
Yep, it's clear to me.
Okay.
Yeah, Aniket, this part, right, where it is not learned. So this particular part where it is not learned. So when VTAP 3 does an ARP sync, because it's mentioned for a VTAP IP, the inner source MAC is changed to the VTAP IP.
Inner
Such
source
that
MAC is changed. Yeah, inner source MAC is changed to physical MAC.
Physical MAC of VTAP 3. Now the thing is that the ARP would be learned, but MAC will not be learned.
Yeah.
Right.
Correct.
Okay. This is only, I mean, like, okay. This is only when a bridging and a routing part is mingled up.
Yes. Like you have a
Okay.
VTEP 2 is a bridging VTEP here, right? And there is no SVI here. So yeah, in that case only it will happen.
Okay.
And
Okay.
this kind of issues, right, it is addressed very easily with the help of CVX. Okay, because in CVX, VTEP 2 will advertise the MAC address of H2. So then it will learn via CVX. But when it is all dynamically learned, then it's a problem.
Okay. In EVPN also, this issue is
EVPN,
not
yeah,
seen.
this issue is not seen. Yes.
Okay. All right. Yeah. Thanks. Thank you.
Okay. Okay. So this was about H. Yeah. Anyone?
Yes. So yeah, what will be the outer source IP, the ARP seed packet?
Yeah, the outer source IP.
Yeah.
For during ARP sync, you mean?
Yeah. Physical IP only, right?
Physical IP.
Okay. Because the MAC is physical MAC, so the IP.
Yes.
Okay. Yes.
Exactly. Okay. And this was about H2. Okay. Now let's discuss about this H3. So VTEP 1, let's say VTEP 1, okay, not this. Let's say I move this host here. Okay. Like H2 is connected behind VTEP 3. Now, when VTEP 1 sends an ARP request for 100.1.1.20, what will happen? Same thing, right? When H2 will send an ARP reply, it will send it to the VMAC. Correct? Same thing. But in this case, this VMAC is also configured on VTEP 3. Right? So this is also configured on VTEP 3. So VTEP 3 is, what will it do? It will, first of all, it will learn that ARP. It will learn the ARP of H2. And it will also flood. It will also flood to VTEP 1 and VTEP 2. VTEP 2 is not going to do anything with that, but VTEP 1 will learn that ARP. So this is also another kind of sync. Okay. So these are the two kind of syncs in VXLAN we have. One is when a VXLAN ARP reply is received on VTEP 3. See the difference. Okay, here the ARP reply is received on VXLAN interface, but here the ARP reply is received on local interface. If the ARP reply is equal to DMAC is equals to VMAC, then it will flood it. Yeah, sorry.
Yeah, here it will not change the.
No, it will not change.
So the MAC will be learned from VTEP 3.
Yes, it won't change the source MAC. Yes. Okay. Okay, so this is about standalone VTEPs that we discussed so far. We'll also discuss a bit about MLAG, how that works. So whatever sync behavior I discussed so far is with respect to VXLAN ARP sync. Okay, and then there is a MLAG ARP sync is also there. So let's make an MLAG here. And in MLAG, every configuration is same. There is no difference between VTEP 1 and VTEP 4. All configurations are exactly same. Except if you use a physical IP in the SVI, then you don't want to configure the same physical IP on the SVI. Or you can question what will happen if you use same physical IP across every VTEPs. What will happen? That's also a discussion for you guys. Okay, so let's say you are using VARP, and someone is saying that we need to configure different physical IP on all the SVIs on across all the VTEPs. It has to be different physical IP. But what if I use same physical IP? Will that break anything? So that's something that you can think. Anyway, so in this case, this is MLAG. What's the time? Are you guys okay if we just extend for maybe a little bit more, or is it okay if we continue? Preetham, are you here? Don't think Preetham is here.
Yes, Aniket.
Okay. So now let's talk about MLAG. Okay, so far whatever we have discussed is for standalone VTEPs. There is no MLAG here. But in MLAG, one thing that would happen is, so let's talk about physical let's talk about VARP first. Okay, so when you have VARP configured, then whenever this VTEP1 will send the ARP request, H1 will send the ARP reply directly to VTEP1. Even if it goes to VTEP4, VTEP4 will simply switch it and send it to VTEP1. Okay. Another thing is, if a host sends an ARP reply, if a host sends an ARP reply, like let's say H2 sends an ARP reply destined to the virtual MAC of VTEP1, VTEP4, and let's say the ARP reply is received only on VTEP1, it will do and sync with VTEP4. So VTEP4 will also learn that ARP. Okay. So if VTEP1 sends an ARP request for H2, and H2 is sending that ARP reply with the DMAC as VTEP1 because it's VARP. Okay. With ARP reply, DMAC equals to VMAC. And when that ARP reply will be received here, okay, then what will be the ARP? The DMAC will be the VTEP1, right? Physical MAC. So when it will learn that ARP, it will sync it with that. And not just VXLAN. Even if it receives that ARP reply on the peer link also, it will sync it with MLAG peer. If it receives that ARP reply via like this, it will sync with its peer. So whatever ARP reply it gets, basically this is what you need to know. Whatever ARP reply VTEP1 will get, it will always sync it with VTEP4, whether it is received on VXLAN interface or whether it is received on the peer link or whether it is received on this MLAG port channel. It will sync with its peer. That's a very simple thing, but yeah, you need to remember this, okay? In MLAG, whenever you get ARP reply, you will tell your peer. And you can check that in counters also. Show VXLAN counter VARP, you can see the ARP cache sent to its peer. And same thing with IP address virtual also. And in IP address virtual, it is even more necessary to sync, okay? Because in ARP sync, the ARP reply, when H1 sends the ARP reply, okay, let's say the ARP request is initiated by VTEP1, but the ARP reply, which is destined to VMAC, can go to VTEP4 and VTEP4 can consume it. So there is a more of need to do ARP sync. So here also VTEP4 will sync with VTEP1. If it doesn't do the ARP sync with VTEP1, then VTEP1 will never learn the ARP. Okay. Actually, sorry, I might have. Actually, I don't think we do ARP sync with VARP. Because in VARP, we always get the ARP reply destined to its physical MAC. Yeah, sorry about that. I don't think we do that ARP sync here. The ARP sync is only done with virtual IP. Yeah, I think I got confused with IP address virtual, but In VARP, basically, if it sends a ARP request, VTEP1 will always get that ARP reply. So there is no need to do a ARP sync here. But in case of IP address virtual, that ARP reply can be consumed by VTEP4. So it has to sync with VTEP1. I think there is a question. Yeah. Okay. This is a bit confusing, I know. So we all need to test this. Okay. I'll give my lab and then you can just test all these things. But these are pretty much about the sync behavior. And also for IP address virtual, if the ARP reply is received on this MLAC peer, it will sync with VTEP4. IP address virtual, there is always ARP sync. Yeah. I think Bhavna sent something. Yeah. Correct. You can just go through this slide. This has the explanations. But I think we don't do ARP sync for physical IP. Do you remember, Bhavna?
Yeah, ARP sync is only for virtual.
Yeah, IP address virtual.
Yeah.
Correct. Because in VARP we send the ARP request with a physical MAC, so it will always get the ARP reply. So it will never be a case where a VTEP is not learning the ARP. It will never happen. Okay, sorry, it's going a bit long. Any questions? I will share this recording, so at any point, if you are getting confused, you can just revisit this. I want to do the lab. I don't know if we have time. Or maybe if you want, we can continue the lab tomorrow. Is that okay? Maybe you can just, you can just go through these concepts once again internally, and tomorrow in the lab we'll basically see all these things. We'll take captures and we'll check how the packet is getting synced and everything. Okay. Any questions, guys? Anyone? Are we good with today's session then?
Yeah, Aniket.
Yes, sir.
Okay. All right, I'll stop the recording.